All right, so let's continue our discussion. If you remember, we talked about the concrete components. We talked about the different types of cement, type 1 to type 5 all the way. If you remember, we talked about different sort of characteristics of concrete and what is admixture, that would be a new agent or new component can be added to concrete for different reasons. Talking about the density of concrete, normal weight concrete, lightweight concrete, we define what are their intervals, all right? Now, let's talk about the let's just continue our discussion. Now we're talking about the mechanical properties of concrete. All right. So let's see here. Okay. So and one important characteristic of concrete is when we are talking about the compressive strength of concrete. All right. So compressive strength of concrete. We show it with F prime C. What is that? For example, if I make a cylinder, concrete cylinder, all right, if I break this under compression with a force of P, okay, and let's assume that the area of concrete is shown by AC, the cross-sectional area where you're applying the normal compressive force on it, all right? So if you have this situation, F prime C would be the maximum force over the area of concrete, all right? So in some countries, like our country, we use cylinders, usually 4x8 or 6x12. So 6x12 meaning what? Meaning this 12 inches, this to be 6 inches, all right? Also, we can have 4x8, which is more common these days, 8 inches by 4 inches, okay? So if you want to understand the compressive strength of concrete, usually, again, it depends on different situations, right? Usually we want to use 3 of these tests and make an average of 3 specimens, right? So we break 3 of them, and then the average number would be the compressive strength. If you use 6x12, usually the average of 2 cylinders would be used to basically nominate the strength of concrete, the compressive strength of concrete. If it is not clear yet, for example, you're gonna test it, you realize that, all right, it is 2,500 psi at the first test, first specimen, 3,000 psi. Sorry, for the second one, 2,750 psi for the third one, right? Make the average, and it would be 27 psi. Just add them and divide over 3. Sorry. This would be the F prime C of that concrete. Okay. So this is the cylinders. In some countries they use cubes, so they make cubes, right? Usually 4 inch by 4 inch by 4 inch would be the size. Usually 4-inch cube. Right? Same idea. You push it, right, from both ends with the force of P. Your F prime C would be P max over area. Area for this case would be this area, because that's where you are pushing. That is the side, the cross section. You are applying your normal compressive force. All right. Having this said, let's just look at the different range of Oh, one important thing. So this compressive strength of concrete, in 28 days, you are reaching to almost a maximum compressive strength. 28 days from the time that you're casting a fresh concrete. If you think about it, the concrete is a liquid, almost like a liquid. When time goes on, it's just getting stiffer and stiffer and stronger and stronger. At 28 days, you are reaching to your maximum strength almost. All right. So that is your threshold or your milestone, I would say, that you would say, all right, this is the time that I can load my concrete. All right. Okay, and let me erase. So that's what I'm gonna do. I'm gonna erase the page and just rewrite on it. So make sure that you are just, if you are writing on your notes, make sure that you are just keep writing when I'm just writing here, because I'm gonna erase and just continue. That's just a way going from one page to another page here. All right. Probably what I can do first is a little bit just make this page smaller. All right, I think that makes more sense. Okay, so another thing, just important thing about the 28 days, I want to tell you that if you look at the graph of time versus F prime C of concrete, it goes like this. It goes up and it just flattens as it goes. All right. So for example, here, it is your so here is the 28 days. All right. So on this date, it is where you are basically selecting the primes that you are calculating based on. All right. As you can see, a little bit you are going higher, but as you can see, it is getting flattened. So that increment is not that much. That's not significant. So all right. So not significant. So you don't care about that. You would say, all right, 28 days would be enough for me to just start to load the concrete. So for example, this is the 7 days. 14 days, right? So you're still getting something in 7 days, but your good strength is gonna be reached to at 28 days. Excuse me. All right. So compressive strength is the range from 2,500 psi to 20,000 psi. All right. So usually it ranges from this number to this number in terms of psi. Also, it can be expressed in terms of ksi, right? So as you can see, there is like a large interval you have for the concrete. But ordinary concrete usually hovers about 3 ksi to 4 ksi. This would be the ordinary concrete we are dealing with. Pre-stressed concrete, which is the whole story itself, it is a graduate level course for concrete. Higher strength of concrete needed for this type of concrete structures. From 5 to 6 ksi. All right. So let's just bring some water beside me. All right. So now that we understood what is a range of concrete and how different it can be, let's talk about the stress strain curve of concrete as well. Okay. So if I look at a stress or F prime C versus a strain, right? The concrete is a fragile, sorry, it is a brittle material, right? It is a brittle material. So it goes something like this, okay? So on this top, which is the highest strength, the ultimate strength of concrete, this is F prime C that we are looking for, all right? Usually on the strength of 0.02, we will reach to that. That is what it's telling you. This is where you read F prime C usually. Okay. So if you want to talk about the strain corresponding or counterpart of F prime C, the strain would be 2000. Poisson's ratio, another component, another mechanical properties. It is also shown by nu as well, mu or nu. Ratio of lateral expansion to longitudinal shortening ranges from 0.11 for high strength to 0.21 for low strength concrete, with the average of 0.16. So nu of concrete is usually 0.16. All right. What was the definition? It is the epsilon for lateral over epsilon for longitudinal. Remember from mechanics of materials? All right. So these are mechanical properties of concrete. We have learned the compression, strength, and Poisson's ratio. Okay. We're going to talk about the stress strain curve more. Okay, let's go to the next slide. A stress strain curve for concrete. Curves are typically linear in initial range from 0 to 1/3 to half F prime C. Okay. So what is telling you? Let's look at it here. As we discussed, it is something like this. So this is your F prime C, correct? The ultimate strength, the highest strength. Prime C. So by this, I'm trying to say that it is sigma, the compressive stress. So I hope that it doesn't make you confused at why I'm just saying F prime C and F prime C. So it is a compressive strength. F prime C is a specific number which I selected for the highest strength of compression of concrete. Or compressive stress, we can say too. All right, it says typically curves are linear in the initial range from 0 to 1/3 or half F prime C. So you remember that from mechanics of materials that we are in a linear region, right? So we go straight and then we start to curve, right? So this is linear region. So in concrete, it says it is from 0 to usually half or 1/3 of F prime C. All right, so F prime C is here, right? So from to half or 1/3 of F prime C, from 1/3 to half F prime C, this region goes linear. That's estimation. Why we are not so sure? Because it is a brittle material. It is hard to exactly capture different behavior on this stress strain diagram. Non-linear in the intermediate region, of increasing curvature until ultimate f prime c. So at this point, it became non-linear, right? It is, we can call it intermediate. Intermediate region, if I can spell it. Intermediate. All right. In the final range, the strength continues to increase with decreasing load capacity until failed. So that's the final range, right? That is the final range. Okay, final range here. Okay. Concrete does not have a definite yield point like steel. It is assumed that the normal strain concrete fails at 0.03. All right. This point usually is said to be 0.003, but it is not definite number. That's estimation for final strength of concrete. But this was different if you remember the corresponding point. So look at this. This sort of X and Y couple, they are representation of F prime C for you. If you remember, the corresponding strength to F prime C usually is 0.002 for this point. So, and on 3 would be basically, it is the concrete would be filled truly, totally, just gonna collapse. It's gonna crush all the way. Crush would be a good word for it. For concrete, crush would be a good word. All right. Okay. Let's continue. All right, so let's look at on the graph. So